Welcome to 1.3. Today we want to begin to look at the idea of what is an inductive and a deductive argument. So I watched the last two videos that I did, and I look like I'm on drugs or something, so I'll try to do a little bit better and stay a little stiller. How's that? We want to talk about inductive and deductive arguments. An inductive argument, how do I know? We classify them by inferential claims. So what am I saying? Inductively, that the premises are true. If they're true, then the conclusion has a high probability of being true. In deductive, if the premises are true, the conclusion is certain to be true. Here's the two things to remember. Number one, inductive, probable. Deductive, certain. So inductive, probable, deductive, certain. If you keep those two words together in those two groups, inductive, probable, deductive, certain, you'll have a much better foundation and understanding as we get into chapters 4, 5, and 6. Okay? So intuitively, what is the inferential claim being made? So we're looking for keywords. So we're looking at it saying, what are keywords? What are some things that help me to understand? So we saw on page 3, section 1.1, we saw conclusion and premise indicator words. Okay? That will sometimes help me in understanding whether an argument is inductive or deductive. When I look at certain words like there's a good chance of, I know that it's inductive. When I see certain things such as mathematical, I know it's deductive. Okay, so or definition is given, I understand it's deductible. So keep those things in mind. Okay. So here are the four types of deductive arguments we're going to look at briefly today, and then we're going to look at some inductive as well. An argument based on mathematics, an argument from a definition, and then syllogisms, which is what we'll be using primarily in chapters 4, 5, and chapter 6. An argument based on mathematics says that a mathematical formula is applied or a principle is applied to a specific case. So in a simple example, the walls in the square room are 10 feet long. Therefore, if I have a wall that's 10 feet, it's a square room. I know that this wall is 10 feet. If I want to carpet that room, I know that if I multiply 10 times 10, I come up with 100 square feet. So then I know that I need 100 square feet of carpet. That's deductive. Okay, it's black and white. It's cut and dried. I don't say I need 102 square feet. Why? Because I know the walls are 10 by 10, so I know exactly the size of carpet that I need for that room because the walls are 10 by 10. Okay, now keep in mind that this doesn't deal with statistical arguments that do not fall under statistical arguments do not fall under this category. So when we start dealing with standard deviations and differentials, those types of things are not certain. There's not the element of certainty. It's like saying that here's a poll. We did a poll. We polled 2,000 people, and therefore there's a variance of maybe 1 or 2% each direction, plus or minus 2%. Okay, that would become a lot more inductive because we're taking away the certainty of it. Now we're saying there is a margin for error. Arguments based on definition. This one's easy. An example, it's a definition. Example, a Dalmatian is a spotted medium-sized dog. Okay, so in a syllogism we would say, categorical syllogism, Dalmatian's a medium-sized dog, Rover's a Dalmatian, therefore Rover's a medium-sized dog. If we know that the Dalmatian is medium-sized, and we know that Rover is a Dalmatian, now we know deductively that Rover is a medium-sized spotted dog. Okay, syllogisms. When we deal with syllogisms, we're going to start dealing with terminology such as all A are B, no A are B, some A are B, some A are not B. Now this is in categorical syllogisms. We will do a lot with categorical syllogisms, chapters 4 and 5, when we start dealing with Venn diagrams and other types of ways of proving truth and validity. Okay, but once again, it's deductive. We know that all are, no are, some are, or some are not. Okay, that makes it very simple for us. And we'll see the simplicity of that right now. You look at it going, I'm confused. I'm looking at it like a dog at a new dish, right? But as we get into it, we're going to see it much clearer. A categorical syllogism would be all dogs are mammals, so all D are M. No mammals are fish, no M are F, therefore no dogs are fish. Okay, so we're going to see that in great detail, right? So we'll keep that in mind, and we'll come back to that. So I don't want to cover that now. It will be covered later. A hypothetical syllogism has one or more hypothetical statements. A hypothetical statement has the form of if this, then if A, then B. If the economy declines, the Democrats will lose over 20 House seats. The economy will decline, therefore, the Democrats will lose over 20 House seats. Okay, now, once again, hypothetical. We don't know if the economy declines. We're saying that it is, and we are making an assumption that the Democrats will lose over 20 House seats. So, therefore, it's more hypothetical. It's a lot less specific or certain, as we saw with categorical syllogisms. If the Yankees win the World Series, the forces of evil have prevailed. If the forces of evil have prevailed, the end times are there. Therefore, if the Yankees win the World Series, the end times are here. Okay, the likelihood of that being sound is not very good, or being true or valid. And so we begin to see the difference between categorical and or hypothetical. A disjunctive syllogism is a syllogism that includes an disjunctive statement, such as an and or statement, okay, as one of the premises. So in other words, example, I will have to leave now or I will be late for class. I can't leave now, so I will be late for class. Okay, it's disjunctive. There's a separation there, right? So keep that in mind. Inductive arguments, 6 types we want to look at. Sorry, prediction, analogy, generalization, argument from authority based on signs, and a causal inference. So let's look at these, and we want to try and get this done within about 10 minutes. So let's look at them, and we'll kind of go through these a little bit quicker. And I'm going to be looking at my book a little bit, so just don't be offended if I'm not looking at you. Okay. A prediction draws a conclusion about future events based on currently known premises. Okay, so I'm predicting something. The teams Peyton Manning plays for have generally had winning seasons. University of Tennessee, and then at Indianapolis, now with the Broncos. Therefore, since he is playing for the Broncos this year, the Broncos will have a winning season. Now, this was written at the beginning of last semester, so I shouldn't say that on a recording. This was written in fall of 2013. Okay, so we are now talking to you, and I'm making this in January of 2014, and we know that the Broncos did have a winning season. An argument from an analogy. An analogy argues that things with a known set of similarities will have similarities in other areas as well. I like Thor and I like Iron Man movies. Since the Avengers has the same characters, I will like them as well. Okay, so an argument from an analogy saying is because I like this and I like this, then I will like that because it's similar. Okay, generalizations is an argument that draws a conclusion about a general population based on a subset of examples. I went to Charleston and the people I met were polite. Therefore, most people from Charleston are polite. Okay, I'm generalizing that because the people I met that were polite, everybody in Charleston or most of the people in Charleston are going to be polite. Okay, we make generalizations like that. We say since the greater percentage of population in Dallas goes to church, therefore most of the people in Dallas are Christians. Okay, that would be a generalization. We don't really necessarily have the proof to back it up. It's just that I'm generalizing that because of what I know or what I see. Argument from authority. This argument from authority draws a conclusion based on the authority's position or opinion. My doctor says I need to cut down on fatty foods to lower my cholesterol. I think I'll lay off the hamburgers. Okay, so we begin to see this that, it's a good argument. My doctor says I should do this. I'm going to lay off on hamburgers because I need to cut down and lower my fatty foods and lower my cholesterol. What we need to make sure that we understand, though, is that authorities are not always true or correct, and sometimes authorities do make mistakes. An argument based on signs bases its conclusion on a sign. Okay, similar to authority, right? So this says Diet Pepsi on the outside, therefore it must contain Diet Pepsi. Okay, now that's a great. I'm doing it based on the fact that it's telling me what it is. Now I could have poured, rum or something else in here. That will show up a little bit later in this video. if that's truly what happened. But you get the concept, right? It tells me it's Pepsi because the outside tells me it's Pepsi, therefore the contents are probably Pepsi. A causal inference draws a conclusion that one thing caused or causes another. Every time I get a latte or eat ice cream, I get stuffy. I must be lactose intolerant. Okay, and so therefore it has degrees of probabilities, right? I get this, therefore I get stuffy, therefore this is a possibility. Okay, and there we come to the end of what we want to talk about. Go ahead and pursue section 1.3, get the homework assignments completed, and then watch the video for section 1.4.